Aging, it feels like this, fixed countdown, an inevitable part of life we all face. But what if that wasn't entirely true? What if we could actually influence its speed, or maybe even reverse some of its effects? Today, we're doing a deep dive into some really fascinating sources that tackle this very question head-on. We've pulled together some incredible insights from the National Institutes of Health, and also a pretty thought-provoking perspective from a Nobel laureate at Harvard. Our mission, like always, is to pull out the most important nuggets of knowledge. We'll explore what aging actually is, how science is getting remarkably good at measuring it, what interventions might be coming down the line, and maybe surprisingly, what we might be doing right now to either speed it up or hopefully slow it down.
Yeah, it's definitely an exciting time to be looking at this. For so long, medical science, it primarily focused on treating individual diseases as they popped up. Heart disease, cancer, diabetes, dementia. But the big shift happening now is this understanding that aging isn't just like wrinkles or gray hair. It's actually the single greatest risk factor, the common root cause for pretty much all of these major diseases. So addressing aging itself is kind of becoming the holy grail of preventing, not just treating, the illnesses that often define later life.
Right. Okay, so let's unpack this then. If aging is this central process, what is it at its core, according to these scientists?
Right.
Dr. Tony Weiss-Corey, who researches brain aging out at Stanford, he uses a pretty straightforward analogy. He compares aging to a car. When you drive it off the lot, it's perfect, everything works. But over the years, with constant use, parts degrade, wear and tear builds up, and eventually things just stop functioning quite as well.
That car analogy, it really helps visualize the basic idea, doesn't it? But, on a molecular level, our bodies are just way more complex than any car. We have these incredible, built-in repair mechanisms designed to fix daily damage. But even these really sophisticated systems, they become less efficient over time. And this leads to a gradual buildup of defects and damage to our molecules and cells, things like DNA damage, proteins misfolding, cellular senescence. Eventually, enough of this molecular damage starts to impact the function of whole organs and systems. And this is the precise level that NIH-funded researchers are trying to understand and crucially intervene in. And it raises the question, if aging is this molecular buildup, can we actually quantify it, put a number on it?
Exactly. Because we all know people who seem to, defy their birth certificate, right? And chronological age might say you're 50, but maybe your body is operating more like a 65-year-old, or sometimes maybe even like a really robust 40-year-old. Scientists are moving beyond just birthdays to measure something they call biological age.
That's right. Biological age is a much more accurate reflection of that molecular damage we were just talking about. The damage that builds up over the years and eventually leads to disease and disability. Dr. Daniel Bielski, he's at the Columbia Mailman School of Public Health. He explains how researchers measure various biomarkers, in your blood and other tissues. Then they compare these markers to what's typical for people of a given chronological age. Basically, they can tell you, okay, based on these markers, your body's functioning like a 55-year-old. Now, if you're chronologically 65, that's pretty encouraging, right? But if you're only 45, it suggests you might be aging a bit faster than average.
That's incredibly powerful. Wow. But Bilski's team took this concept of biological age even further, didn't they? Instead of just an aging clock, which tells you sort of how much you've aged, they developed something like an aging speedometer. It's called Din Pace.
Ah, yes, Din Pace. It's quite the innovation. It focuses on specific chemical modifications to our DNA, something called DNA methylation. These are patterns that change demonstrably with age, and they're incredibly informative. The algorithm itself was developed using data from the Dimidin study, which is this remarkable long-term health study that's followed over 1,000 people in New Zealand since they were born back in the early 70s. So the algorithm identifies DNA methylation patterns that correlate with changes in 19 different biomarkers over a 20-year period. And what they found was pretty stark. Individuals with a faster rate of aging, as measured by this Din Pace, they faced a significantly greater risk of poor health, developing chronic diseases, or even dying earlier. The real breakthrough here, I think, is moving from this sort of fuzzy notion of aging well to a concrete, measurable speedometer. It could literally tell you if your lifestyle changes or maybe even new age-slowing treatments are actually working at a biological level. So for you, this could mean your doctor gets an alert saying, hey, your biological age seems to be accelerating, maybe prompting them to recommend certain cancer screenings a year or two earlier, or perhaps later, depending on your individual pace. And what's truly remarkable is that Dr. Weiss-Corey, who we mentioned earlier with the car analogy, he's also shown it's possible to measure the aging of individual organs based on proteins in the blood. That allows for even more targeted care.
That's a huge leap forward. Okay, so if we can measure aging with this kind of precision, the really captivating question arises, can we actually turn back the clock on some of its effects? And nowhere is that question more poignant, I think, than when we talk about our brains, specifically this ability of our neurons to strengthen connections, what scientists call synaptic plasticity. That unfortunately decreases with age and it impacts learning and memory, particularly in a crucial area called the hippocampus.
Yeah, and this area of research has delivered some genuinely groundbreaking discoveries. Back in 2014, Weiss Corey and his colleagues, they made a remarkable finding. They showed that blood from young mice could actually have beneficial effects on the brains of aged mice.
Young blood. Really?
Yeah. When introduced to an old mouse, this young blood actually changed gene expression related to synaptic plasticity and crucially improved their learning and memory. And even more remarkable, human umbilical cord blood plasma had similar positive effects on these aged mice. It suggests there's some kind of universal factor at play.
Wow. And the team didn't just stop at young blood, they actually pinpointed the specific mechanism, right?
They did. They zeroed in on a protein called tissue inhibitor of metalloproteinases 2, or TIMP2 for short. They found that levels of TIMP2 went down with age in the mouse hippocampus, but when they injected aged mice with TIM2, it actually promoted plasticity and improved their learning and memory.
Okay, so it boosted it back up.
Exactly. And here's the kicker. When they took cord blood and depleted it of TIMP2, removed that protein, it lost its beneficial effect. This really strongly suggested that TIMP2 was responsible for these sort of anti-aging effects in the brain. It means that at least some consequences of aging might not be irreversible decline,
Yeah.
but maybe more like a deficiency that could potentially be corrected.
That is fascinating. So it's not just damage, it could be something missing.
Precisely. And this research is part of a really rapidly moving field. It really opens the door to incredible possibilities. Broadening our view a bit, Nobel laureate Venki Ramakrishnan from Harvard highlights other major directions in this area too. For example, there are drugs like rapamycin. It was first isolated from a bacterium found on Easter Island, believe it or not.
Easter Island? Huh.
Yeah. Rapamycin targets something called the TOR pathway in cells. You can think of it like a master regulator of cell growth and metabolism, kind of a central control panel that senses nutrient availability. By influencing it, rapamycin seems to affect cellular signaling linked to age-related changes and diseases. It's getting renewed attention for its potential to maybe reverse aspects of aging.
Interesting. And beyond specific molecular targets like that, Ramakrishnan also highlights an even more radical, almost futuristic approach, doesn't he?
Indeed. He points towards cellular reprogramming. This is a method of taking fully developed cells like skin cells and essentially turning back the clock on their development. It was famously demonstrated by Shinya Yamanaka, who showed he could create what we now call induced pluripotent stem cells.
Pluripotent, meaning they can become other types of cells again.
Exactly. Pluripotent means they have this remarkable ability to then develop into almost any cell type again. It's like a truly profound reset for cellular health, a revolutionary concept in regenerative medicine.
Okay, wow. Cellular reprogramming, young blood factors. While those breakthroughs are incredibly exciting and hint at amazing future therapies, let's bring it back to Earth for a moment. What can we do today to at least slow the aging process down? Dr. Belsky reminds us that the answers, and I'm quoting him here, none of them are very exciting, but he emphasizes they are profoundly effective. Physical activity is described as, quote, the closest thing to a fountain of youth that we know of, and healthy eating also plays a major role.
Absolutely. And one of the most well-studied lifestyle interventions, one that consistently shows powerful effects across species, is calorie restriction, or CR. To explain it simply, it just means reducing your total caloric intake while, and this is crucial, still getting enough essential nutrients. Studies, spanning from yeast all the way to rodents, have consistently found that CR can increase longevity and delay age-related diseases.
Right, the big question, though, is does this apply to humans? That's where the NIH-funded calorie study comes in, right?
Exactly, the calorie study.
Over 200 healthy, middle-aged volunteers participated. One group tried to cut their daily caloric intake by 25% for 2 years, while the other just ate normally. Now, the CR group, they managed an average 12.5% calorie reduction, which, to put that in perspective, for someone on a 2,000-calorie diet, that's about 250 fewer calories a day, roughly the calories in, say, a large banana or maybe a small bagel. For someone like me who really enjoys their morning pastry, that sounds like a serious commitment, but the results apparently really speak for themselves.
They really do. The calorie study results were quite significant. Participants in that CR group, they showed a much slower pace of biological aging,
Mhm.
measured by clinical blood biomarkers, and they also showed a small but significant decrease in their Dunedin pace score, that aging speedometer we talked about.
Oh, okay.
What's intriguing here is that even though there was a small decline in muscle tissue in the CR group, there was no significant loss of muscle strength. That suggests maybe an improvement in muscle quality.
Interesting distinction.
Yeah. And further analysis of muscle biopsies revealed that CR actually modulated the expression of over 1,000 genes.
1,000 genes.
Yeah, genes related to muscle formation, repair, circadian clock regulation, and even inflammation, which is truly remarkable for just a simple dietary change.
Wow. So what does this all mean for us, right now as we navigate our daily lives? Dr. Luigi Ferrucci, he's the scientific director of NIH's National Institute on Aging. He's optimistic about CR, but he kind of echoes Dr. Belsky's view. He emphasizes that the most impactful measures are already readily available to everyone.
He truly believes the magic pill is already here. Ferrucci recommends really practical, accessible measures, being physically active, not smoking, maintaining a healthy weight, getting good sleep,
Yeah.
getting all your recommended vaccines, preventive cancer screenings, and treating conditions like hypertension and high cholesterol. He states, and this is a really powerful quote, people have demonstrated that if you do these things, which are all feasible, you can increase your life expectancy by 10 years. We don't need a magic pill. The magic pill is already here.
It's quite humbling, isn't it? After all that cutting-edge science and billions of dollars flying around, the most powerful tools are often the simplest, oldest wisdom. Which brings us to a slightly different angle, maybe a more philosophical one. Beyond the science of how we might slow aging, Ramakrishnan, the Nobel laureate we mentioned, he raises a really profound question. Should we even pursue immortality or living for a very, very long time?
It's such an essential consideration, isn't it? Pushing beyond the scientific can we to the societal should we. Ramakrishnan's perspective is that while death isn't necessarily fixed by some physical or chemical law to happen at a specific time, indefinite longevity, or even just radical life extension,
Yeah.
it would require huge breakthroughs, obviously, but also really significant moral pondering. He actually likens the question to that of colonizing other galaxies.
Wow, that's a big comparison.
It is. It's a monumental undertaking with profound implications for humanity and how we define life, purpose, society itself.
And meanwhile, this explosion of aging research, fueled by billions in government and private spending, it's also led to a booming consumer market. It's forecasted to hit something like $93 billion by 2027. That's a massive amount of money being spent on products promising longer life.
And this definitely raises an important question for you, the listener, as a discerning individual. Ramakrishnan specifically highlights the rise of false or exaggerated claims by companies promising longer life. He gives an example of supplements designed to lengthen telomeres. Those are the genetic segments that shrink with age. You can find them on platforms like Amazon. But these products often lack FDA approval. They lack rigorous clinical trials to actually back up their claims.
Right, buyer beware.
Exactly. So how do you distinguish genuine scientific progress from, marketing hype in this rapidly developing, often unregulated field? It absolutely requires critical thinking and, frankly, a healthy dose of skepticism.
So, quite a journey today. We've gone from understanding aging at a molecular level to these exciting new ways to measure our biological age with things like Dunedin pace, to the incredible possibilities of reversing brain decline with factors like TIMP2 and even cellular reprogramming. Then we grounded ourselves back in the practical, powerful impact of lifestyle choices like calorie restriction and just basic healthy habits, and finally touched on those profound questions of whether we should pursue radical longevity and the importance of discernment in this very crowded marketplace.
Yeah. And while the quest for radical life extension definitely continues with some exciting, almost science fiction-like advancements maybe on the horizon, the most potent tools for a longer, healthier life are, as we've discussed, they're already in our hands. But critical thinking remains absolutely essential in navigating the sheer volume of information out there, separating what's truly impactful from what's merely speculative or sometimes even harmful.
So here's maybe a provocative thought for you to consider as we wrap up. Given what we now know about the amazing built-in repair mechanisms of the human body and the proven profound power of lifestyle choices, what if that magic pill for a longer, healthier life is already here? And the biggest challenge isn't actually scientific discovery, but simply our willingness to embrace it.